name's Justin. I'm a lead developer at Northwestern Mutual. It's a large financial services company based out of Milwaukee, Wisconsin. Kind of showing you here some experience. I've worked government. I've done government research for a long time. I worked at startups. And then I went off to Fortune 500 financial services companies to chase the money. Just kidding about that. My fun is finding new technology, as all technologists love to do. Specifically, I love programming languages, which is what drew me to the Beam ecosystem. And I've been toying and using Elixir for about 5 years, and the overarching Beam ecosystem now for over a decade. So agenda. We're going to go over how can Elixir fit into your organization, why most organizations will choose not to do this, features of Elixir that can increase adoption. This is going to be a very technical portion of this. We're going to take all of that and we're going to spin it and turn it into business value and try and figure out the best way to, as technologists who love technology and want to use the newest and coolest thing, to turn it into something that business leaders from your C-level execs all the way down to potentially your managers and directors that could see to help give them value to potentially bringing it in. And we're going to fake try bringing it to an organization. I'm going to apologize for 2 things right away. One, I'm a big lover of memes, so there will be a lot of memes in the technical section. I'm sorry about that. Number 2 is I'm a big fan of D&D and tabletop RPGs, so this may align with how you do skill checks in D&D, as you'll find out in a few slides. So let's get started. So how functional can fit? There are less errors. If you have ever coded in C, even potentially Rust and gone into unsafe Rust, even Java, C#, JavaScript, any of those, it is very hard in these languages to cause truly catastrophic errors. This is on multiple levels, right? One is you have very safe functional interfaces. You have very safe ways of going through your functions and creating data pipelines. It's a lot safer than your object-oriented or even your multi-paradigm languages. They're simple to follow. If you understand sometimes the obtuse syntax from other languages, you can easily look at something and go, oh, I'm doing this thing, then this thing, then this thing, then this thing. There isn't this idea of, oh, I'm going to go over here, but then I'm mutating inside of this thing over here, and then I'm going to do another thing, right? Anyone that's used JavaScript and tried to make it very class-based probably understands this a bit. Technically, every program you write in a functional language is mathematically solvable. I'm not going to get too into depth in this, but anyone that has maybe pitched it from a technological level knows that functional languages is based on lambda calculus. Being based on lambda calculus means that a program is a solvable mathematical problem. It's a robust ecosystem, maybe not as robust as, again, the big heavy hitters. You have your TypeScript, Python, anything like that. But I will say a lot of the packages that are out there in Hex are very robust. They've been built out. They've been true and tested. Yes, I don't think, I'll have to check again if Hex has one, has an is-even package like NPM, it's really famous. It has robust parallelization options. Again, if you know anything, let's say about the JavaScript ecosystem, we'll take Node for example. It is very well known, slightly misunderstood, that it is a single-threaded system. Again, people that know JS will burn me at the stake for saying that, but it is very much a single-threaded system. You can make it parallel by adding in things like the cluster module, web workers, all of these fancy doohickeys that I don't think a lot of JavaScript developers actually use, but you could. In Elixir, in the Beam ecosystem, this is kind of just there. It's taught. It's right in front. I think if you go to Exercism and start running through the exercises, it's within the first 20 or 30 exercises you run. It is a first-class citizen, and it is amazing. And there are so many other things. It's so much stuff. Now let's get to the bad side of things. Why most organizations don't want it. Reskilling takes too much time. I probably brought this up to 4 or 5 different parts of different organizations throughout my time working, and every single answer I always get is, well, what's the cost of reskilling all our developers? All these developers are Java. They're not gonna wanna learn this brand new system. Oh, everything's a function. What happens when I wanna use my classes and my objects? I have to reskill these developers over here, and that's just not gonna happen because of the upfront cost. Number 2, I talked about high parallelization before, and I think one of my favorite answers I've ever gotten was just utilize Kubernetes. Just put some pods up. That makes it scalable. Everyone knows that. We use the type language based on a hint. I wrote this and everything before the conference, so we'll go with this. We use a type language, Java, C#, TypeScript. We have all the safety we need. Types solve everything. Everyone knows that. Types have never led us astray. CI/CD solves a lot of the issues, right? I talked about how things are complex and it's a very easy language to understand. Well, I don't need an easy language to understand. I have CI/CD. I test it with unit tests and functional tests and end-to-ends, and it all runs in a pipeline, and then it finally will ship. I don't need that fancy stuff. One of my favorites, I actually did get this one time, was, isn't that lambda calculus thing? Like, no one understands that. I actually just got this recently. We already have too many languages at this company. A lot of the times companies, when they grow to a certain size, especially when you get to enterprises, they're going to start saying things like, we need to limit languages. We need to shrink this down. I don't care that you like X. We need to fit it into Y and Z only. So that way we can move people in our teams. And my favorite that we're going to answer throughout this organization or throughout this presentation, there is no business value. There's no business value to a programming language. Switching from X to Y, even though you're solving the exact same thing, no business value. You as a developer are considered an operating expense, and that is it. So what do? Let's highlight the features that truly matter. Were Kubernetes like? Yes, you can run Beam in Kubernetes. It is, you'll read all over the place, it's a match made in heaven. I truly believe that a lot of the features that we're looking at in Kubernetes are built into the Beam ecosystem already. There are just a couple pieces, additional pieces that need to be introduced to make this a Kubernetes-like environment already. We already have the distributed computing built in. We already have supervisors. We already have high multi-threading. We already have ways for nodes to talk to each other and intricate RPC mechanisms. So first, we should already start saying, well, to the business, or even in your own thinking, let's use something lighter. Let's use only ECS with a load balancer or similar offerings from other cloud providers. For service repository or service lookup, use Zookeeper or similar offerings. And if you are still just bent on using some type of container system, use Docker Swarm or any of the other offerings out there. I was thinking about this at length for the past 3 weeks or even longer, but as I kept running through all these things in my mind is Elixir in the Beam ecosystem needs auto-discovery. It needs service auto-discovery. It doesn't need this full-blown Kubernetes system. I'm gonna get a lot of hate for this one. I already know it. Programmers are gonna get really upset that I'm gonna even say this, but I truly believe this. It's just code. If you look on the left, we have JavaScript. On the right, we have Elixir. I even rewrote this while I was on the flight, and that enum.map changed a little bit. But it's the exact same thing. Yes, the syntax is slightly different. Yes, the Elixir looks a little bit different from the JavaScript. And yes, this is a very contrived example. I know that. But it's not that hard to switch between these two. As a developer, I should be able to look at both of these and kind of come up with the exact same reasoning of, it's the exact same thing. I can build both of these, and it has the almost exact same data pipeline. And fault tolerance. I was talking at lunch about this. This is, to me, like the killer feature of the Beam ecosystem that I tout as a technologist. It's fault tolerant. It's hundreds to thousands of tasks available and capable at any time. There's ease of reasoning. Your single-threaded code is multi-threaded code. This is functional programming. We don't have side effects, really. Make sure I said really on that. It is very simple to move your single-threaded application into a multi-threaded application. It is inherent by design. That is not true for a lot of other programming languages. There's a let it crash mentality. Again, talking at lunch about this, and it is amazing to me how many times as developers we're looking at something and we have to build in things like retry logic all the time in absolutely everything we do, from a fetch request all the way up to our pod crashing, to our node acting up, to an architecture or our system coming down, right? We are always thinking about this. We're always going, hey, how do I go through my disaster recovery? And that's one thing in Beam that I've just absolutely fallen in love with, is a let it crash mentality. You should have this mentality with your code that you're like, hey, this thing is going to come down potentially at any time, but I have a way of coming back, and that's your supervisors, right? And finally, hot code reloading. I know this isn't really talked about too much outside of Beam ecosystems, but this is something that's out there. This is something that your developers should be thinking about, that, hey, I have a production incident. I should be able to go in and hot code reload something in. Now again, that sounds scary from a typical development environment, right? You're looking at it and you're going, what did that person just say? But with hot code reloading, we can make sure that we hot code reloaded it also in dev, and we push it up into production, this hot code reload. Our production environment didn't go down, and then we can do all of the previous, change management and all of those things and bring it back down. But this is something that a lot of other systems, right, you create all these other processes to give this feature. So I said all of that. I went on my diatribe. You already know all this, so why am I bringing it up? We need to spin this, though. Business systems and people that think in an enterprise are not going to think like you as a technologist. This is just something that's kind of unknown. Sometimes you'll have business leaders that did come from a technical background, and that's awesome when they did. But most of the time, if you've been working in anything other than, let's say, potentially a startup location or even a medium-sized business, if you've worked in an enterprise, most of your C-level execs, down to your managers, are someone that's just not technically savvy in terms of being a coder. And so we have to spin all of these features into something that they'll now pull business value from. So first, I do want to highlight there were a bunch of awesome talks on actually pretty much each of these topics, and I did not plan any of this with the conference, so this is just absolutely cool. But first, corporate sustainability. This has become a hot button issue for probably the past 5 to 10 years. We've had corporate sustainability efforts all the way from, hey, we're gonna do 80 to 90% recycling, to let's turn the lights off when everybody leaves to save electricity, all this stuff. And I wanna highlight this quote. Research shows that organizations that adopt a long-term incentive scheme for their executives display more long-termist behavior, such as investing in innovation and stakeholder relationships. That's what corporate sustainability is really about. It's giving a long-term horizon. So, why am I highlighting this? Well, if you look over here on the right, there was a poll done in Reddit asking, where do you spend all your time as a developer, or where do you think the most amount of time is done? 149 were on debugging. Remember how I just stated from your programming language that this is a less error-prone language and that everything should just kind of make sense, and that you have hot code reloading, and you also have this wonderful supervisor model? Well, guess what? You have to debug a lot less if all of these other things are true. And I'm bringing this up in corporate sustainability because there was this huge, I think it was 3 or 4 years ago, maybe even 5, where they did a research study, and it was all about the efficiency of the programming language, right? And Rust got touted. And I'm a huge Rustation myself. I love Rust. But I think when we're measuring usability or measuring something like debugging, we're actually talking about corporate sustainability. Yes, the thing in production maybe uses 5% more energy, but it took 20% less energy to get to the point of production. If you're spending less time debugging, you're not running the code, which means it's less time actually running. Hopefully that makes sense, because that's a fun one. One of my favorite topics, I have talked at length about this topic, and I want to quickly poll. How many people here use some type of observability system currently? Is it only logging? Cool. That makes me really happy to see someone that's not just doing logging, because you have observability. So I bring up OpenTelemetry. If you don't know, OpenTelemetry is an OpenTelemetry standard. It is absolutely amazing. Please go look into it. It is probably one of the best things that have happened to enterprise systems and all of that stuff in a very long time. Why am I bringing this up? Well, when you're in an enterprise environment, you have things like risk and audit, especially when you're in high regulatory. If you now can point to a system that can be easily traced, can be added metrics, and you can also have logs and be able to look through all of that with ease, you've now just met your risk and audit capabilities. There are other languages, obviously, that meet this, but this is something that is out in the ecosystem and is very robust. I can clearly tell you that the Phoenix and Ecto OpenTelemetry systems are absolutely wonderful. I've used them personally, and they were beyond my expectations. This is not going to be the same for others. When you have a more fractured ecosystem, let's take Node, for example, maybe you ended up choosing a niche technology, you would have to either develop the telemetry for that system or go without telemetry. I will say that's one thing nice about the Beam ecosystem, it's not as fractured as that. And because it's not as fractured, you should know that the telemetry is most likely out there for this. Developer productivity. Again, we'll go back and tie this to sustainability, but remember how I said at the very beginning that developers were seen as just an operating expense. Well, if you can lower that time in their developer production lifecycle, you've lowered the operating expense. So, you're less time working on bugs because you're less error-prone of a language. Your typical cognitive load of multi-threaded programming is a lot lower. I actually went over to Rust forums to go searching far and wide about this, and yeah, even in a language that touts this kind of like, hey, you're gonna be able to get up and multi-threaded and all this stuff, they're still having the same issues because they give the capability of the developer to get around a lot of the blocks that they want to do. And number two, it is a high cognitive load language. If you've never written Rust, let me tell you, it can be very interesting sometimes. You're also removing and reducing technology span, which means there's less upskilling. So remember how I also went back in the beginning and I stated, hey, you know, I don't want to spend all this money to teach all my developers this. Well, guess what they're doing day in and day out? We added Terraform to our DevOps pipeline. Developers, go learn this. Hey, we added Kubernetes. You know all those Kubernetes commands? Go learn them. Hey, we just added ourselves to AWS infrastructure, so go learn that. Ooh, we're going to use this new AWS service. We're going to go multi-cloud. Go learn that. See how we're expanding the scope of these developers to not just be in a single ecosystem, but we're going to multiple ecosystems that they now need to cognitively switch between. But number two, also need to upskill on that. If we can start reducing all of those pieces and try to get them down to 1, 2, or 3 core technologies, you've now reduced cognitive load, you've increased developer productivity. And I really wanted to highlight this quote on focusing on efficient use of cloud services brings immediate and tangible financial benefits. Unfortunately, most organizations are unprepared to profit from this savings opportunity and they're likely to overspend. And recently just came out that a lot of companies are overspending on their Kubernetes environments because it does auto-scaling for you, but a lot of those developers and a lot of those DevOps are not upskilled on actually how to properly scale and size all of their nodes, pods, and auto-scalers. Like I said, what they saw as an initial operating expense may become their lifesaver down the line. So we gather all that. Let's see if we can convince organization to adopt Elixir. We have a 15 skill check, +1 developer on the productivity. We get a +1 on observability. And we get a +1 on having green compute. Sadly, none of that really mattered because we rolled a 20 on a critical success. But it would have really helped. was going to roll a dice and all this stuff, but I decided against it. And I want to highlight this point of, I know it's kind of fun to think about, but really, every single time you do bring a technology, be it the Beam ecosystem or any other, it is at times a roll of the dice. You are doing a skill check on some type of business entity, right? And all you can do is bring all of these business points to an organization to increase your chance of success with them. But at the end of the day, there are so many other factors that it could still end up in the eyes of the business as a no. Don't feel bad about that, because it happens to all of us. It happens to me all the time when I'm trying to bring up new ideas. So I think we have a tiny bit of time, so I wanted to go over this. This was actually brought up on one of the other talks on legacy code. It was brought up about how you can use property checkers. There's a very famous one in Haskell called QuitCheck, which basically it creates thousands and thousands of unit test cases for those properties and allows it to just work. This is actually kind of known as something called formal methods. And now I'll get into the nitty-gritty of Elixir is a functional language, which means we're utilizing lambda calculus. Because we're based on math, we are technically a mathematically provable software system. I know that is like, it's still crazy for me to even think about. There's an Elixir-based property checker called for prop check. I'm trying to remember, there's 2 libraries sitting out there. And basically what this does is, because let's say you have a function that has 3 arguments, one's a string, one's a list, and one's a key list. Because you have those types already set, and again, because you have no side effects, supposed to have no side effects inside of your function, you are technically provably solvable. And what it will do is iterate through your function with thousands and thousands and thousands of test cases that you don't have to write to prove that your function works. And if you need something more, you can even go crazier. You can utilize formal verification. This is an entire talk unto itself. I won't go into too many details on this, but there's a system out there, it's called Alloy. You should take a look if you're ever interested. But what it does is it creates a formal verification of your software. Systems in high security or high vulnerability will end up using formal methods to test their code and make sure everything is working. And it's basically stating this as a whole system is provable that it does everything that I just said it's about to do, and it does none of the things that I didn't say it was going to do. And I love this quote from Marianne Bellotti. If you've never read her book, Kill It With Fire, I highly recommend it. It highlights and punctuates many of the points that were talked about during the legacy software talk, and it talks about Alloy, the actual formal verification system. So thank you.